A solenoid is a long coil of wire designed to produce a controlled magnetic field. When an electric current flows through these tightly wound loops, it creates a uniform magnetic field inside the coil. To understand the whole, we look at a single loop. According to the right-hand rule, the current creates circular magnetic field lines around the wire, which contribute to the overall field of the solenoid. Inside the solenoid, the magnetic fields from every individual loop point in the same direction. This constructive interference creates a strong, nearly perfectly straight and uniform magnetic field along the central axis. The resulting pattern resembles that of a bar magnet. The field is concentrated and uniform inside, while the external field is significantly weaker and spreads out as it returns to the opposite pole. To calculate the strength of this field, we use Ampere's law. It states that the integral of the magnetic field along a closed path is proportional to the total electric current enclosed by that path. We define a rectangular Amperian loop. Side A lies inside the solenoid parallel to the field, while the other sides are either perpendicular to the field or outside where the field is negligible. The total current passing through our rectangle depends on the number of wire turns it encloses. If N is the number of turns per unit length, the total enclosed current is N times the length times the current in a single wire. By applying Ampere's law to our rectangular path, the equation simplifies. Because the field is uniform inside and zero outside, the length of our path cancels out, leaving us with a direct relationship for the field strength. This gives us the standard formula for the magnetic field inside an ideal solenoid. The field strength B depends only on the permeability constant, the density of the turns, and the amount of current flowing. As we can see from the math, if you want a stronger magnet, you can either increase the electrical current or wrap the wire turns more tightly together to increase the turn density. Solenoids are the backbone of modern technology. They are used to create powerful electromagnets in MRI machines, actuate valves in car engines, and control electronic switches called relays. In summary, solenoids convert electricity into a uniform magnetic field, governed by Ampere's law. By adjusting current and coil density, we can precisely control magnetic force. Generated by Vision Solve AI.